Hi, my name is Javiera Castillo-Navarro and I will present you my work in collaboration with Bertrand-Sud, Alexandre Boulch and Sébastien Lefebvre on semi-supervised semantic segmentation in Earth observation with a new benchmark, the MiniFrance dataset, and the assessment of data representativeness. So, the availability of large public datasets has been crucial for the progress in computer vision because they provide the means to fairly compare our models. This is why the remote sensing community has also published several datasets for different tasks. However, these datasets still have some limitations because they may cover a very small surface or consider only one class or a few land cover classes or only urban scenes and then they lack a variety. But the most important thing is that they are all designed for fully supervised methods. And this is a problem because in real life, annotated data is very hard to obtain. So we should try to leverage non-annotated data to improve the generalization capacities of our models. And our datasets should reflect this situation. This image presents some examples of EO datasets at a sub-meter resolution. And we can see the progress in surface coverage from the classical Potsdam and Weingen datasets to the very large-scale MiniFrance dataset. We also can see that there are only 3 of them that include countryside scenes in the dataset, and MiniFrance is the only one that includes unlabeled images for training. So let's take a closer look to this novel dataset. As we saw, MiniFrance is a very large-scale dataset for semantic segmentation. It includes images from 16 cities in France and considers 15 land use classes. It has many properties that we can see in these examples: the quantity and the variability of data, the higher semantics of classes, and also we have different classes appearances. For instance, here, the urban class, the red one, is very different from one example to another. But the most important characteristic of MiniFrance is that it has been fully designed for semi-supervision. This is that it has a training partition and a test partition, but the training partition contains labeled examples and unlabeled examples for training. We also proposed a small version of the dataset, Tiny MiniFrance, that allows fast development and training without losing generality. But is MiniFrance suitable for semi-supervision? So to answer this question, we present some tools for dataset analysis. So to achieve good semi-supervised learning, we need to satisfy 2 conditions. The first one is the appearance similarity. This is that our training data needs to well represent all appearances in the dataset. And the second one is the class representativeness. And this is that the labeled training partition has to contain all the possible classes in the dataset. But how can we assess it? So we propose a 4-step method. The first step is to encode our images with a pre-trained CNN. So for each image, it will output a vector that encodes for the image appearance. Then we can use a Disney algorithm to visualize them in a 2D space. And so the closer the points are, the more similar our images are. Then, since each point represents an image and an image comes from a city, we can use an one-class SVM to estimate city distributions in this space. That will give us a surface for each city. And finally, we can use these surfaces to evaluate the appearance similarity between cities. This image presents the surface obtained for each city, and we can evaluate the appearance similarity between cities by measuring how much they overlap or how much a surface covers another one. So here we have the same surface by partitioning the dataset and the metrics that we are going to use to measure similarity, and by the results we can see that the label split is not enough to capture all the information in the test split. However, the unlabeled split allows us to recover much more information about appearance. And finally, we can plot the histograms of classes in the dataset, and we can see that the label split represents all the classes. So the MiniFrance dataset satisfies the 2 conditions that we mentioned before. In summary, I have presented MiniFrance, a very large-scale dataset for semantic segmentation in Earth observation that is the first one designed for semi-supervised learning. It is available for download on Dataport, and if you want more information about MiniFrance or our semi-supervised methods, please check our paper. If you have any question, please write me at this address or meet me at the poster session.